So in this video, I want to just dig deeper into the baud rate generator part, the one here I highlighted in red. And really what you'll see is I just will use a timer input, the one that we've seen before, which is just a timer that takes the final value as an input. Let me show you the code. It is the same code that we've seen before. It's just a timer input that ticks whenever it reaches the final value. So technically it's a modulo final value plus one. Remember, because it counts from 0 all the way to final value, and final value is inclusive. So it's final value plus one. So there's nothing new in terms of the code itself. It's just a timer we've seen before. It's just the standard timer that ticks. The reason why I created this video and what I really want to show you is actually how do we compute that final value based on the baud rate that I need. So in here, I'm showing you how we could do this calculation. So let me start by explaining the following. So what I'm showing you in here is the following. Let's assume that I decided what my baud rate is, and my baud rate usually is some sort of 9600 bits per second or something. It's the speed at which I want to transmit or receive data, and it's an agreed upon between the two systems. Anyway, I know that I need to tick at 16 times that rate. So technically, if my baud rate, let's assume that from here to here, it's actually my baud rate, okay? The one that basically, this is from 0 all the way, it counts to a certain number or whatever it is. I know that this is actually my baud rate. However, because I need my timer to tick 16 times within that my baud rate, okay? That means I need to divide it to 1, 2, 3, like 16 different parts, because I need it to tick 16 times that. I'm basically telling you that you have to divide your the period that for the baud rate for 16 times. However, the baud rate itself, it's bits per second, so it's a frequency. So technically, if we're looking at it from a time perspective, we need to take a look at it as 1 divided by b, okay, because I'm looking at the period in here. So what you see in here is the following. If I need like the baud rate that is, let me call it b, that means 1 over b is the time that it takes to go from this one in here to this one here. What I'm saying is like a single bit should take that long to actually send. And of course, because we're ticking at 16 times now, we're going to have to divide it. So in the following diagram in here, what I'm showing you is, well, I need each one of these segments that I showed you in here and here and here. I need basically just, it's 1 over b divided by 16. And I have so many of them, I have exactly 16 of them basically. So if I add this one here with that, with that, with that, I'll get the 1 over b. Anyway, the reason why I'm looking at it, because I really want you to focus on one of these here, because my timer doesn't see the whole thing, it just sees one of the ticks. Okay, so my timer in here, I'm showing you how the timer actually will count. So my timer will count from 0, 1, 2, 3, all the way to the final value. And of course, that means it counts for final value plus 1, because it counts from 0. And that particular period should last for this amount of time. Remember, 1 over b is just the time. Anyway, if you actually put everything together, you're going to get this particular equation. What does this equation mean? Well, I just basically moved b down in here, so it's actually 16 times the baud rate. This is where it's coming from. Okay, and then my final value, of course, it depends on some sort of a t. T is actually the clock cycle, the system clock cycle, which generally we've been using the 100 megahertz as the frequency for my system. That means t would be 10 nanosecond. Anyway, what I'm saying in here is, like, in order for you to go from 0, 1, 2, 3, 4, 5, all the way to final value, okay, that means you counted final value plus 1, and you need to multiply by how long it takes you to do one count, one of the 0, 1, 2. And of course, usually it takes you 1 clock cycle, and that's the period in here. So what I ended up with is the following. I usually have the system frequency or the system period. I usually have some sort of a desired baud rate in here, and I'm really after the final value. So you do a little bit of algebra, you move the t down in here, you move the 1 to the other side in here, and you'll get this particular equation. This equation will help me figure out what the final value should be based on a desired baud rate. So whenever you actually create an instance of this UART and you know what your baud rate is, you should be able to calculate the final value by hand and just basically program it. All right, so let's see an example, or a quick example for that matter. Let's assume that for the final value, for example, I want to find the final value for a timer if my frequency is 100 megahertz and my baud rate is 9600 bits per second. So if you actually just say that, you're going to see that the final value, you can calculate it, it's about 650. Let me just do that in here. Okay, it's about 650, 650 point something, okay, or something like that. So let's assume that it's about 650. So what this tells me, if you put 650 at this particular input in here, you're gonna get it done here that is ticking at 16 times the baud rate, which is 16 times that in here. So it's that fast.